Hello everyone, my name is Agnes Karnika. I'm a product manager here at Rezatec. I come from water industry background, work directly for one of the UK-based water companies. And in my day-to-day job, I get to speak with water utilities around the world and learn about their challenges. So concepts of proactive maintenance or proactive pipe replacement have been around in asset management for a while. And when I speak to water utilities, there is a general good agreement and understanding of benefits that being proactive can bring. One of the most common benefits I came across is future-proofing by staying ahead of failures and making sure enough is done. This is to maintain or improve risk position against the deterioration of an asset and cost of work going up in the future. So in a simple terms, dealing with issues when they are smaller, there is less of them, and they are less expensive to fix. And speaking of deterioration, there is also a general agreement that being proactive can help extend the life of an asset in the first place. It does also help reducing the risk of unplanned downtime and service interruption that has got obviously that direct impact on the customers. On the financial and resources side, all utilities agree that being proactive makes it easier to budget and optimize resource allocation. This, according to some of our customers, can save as much as 30% on repairs alone, simply by avoiding emergency repairs happening unexpected after hours, on weekends and holidays. It's a substantial saving given that most of budgets on both CapEx and OpEx sides tend to be overstretched already. And finally, there is also a case of benefiting from enhanced safety, and for those companies operating in a more regulated environment, the case of being more compliant. So given the wide range of benefits associated with being proactive, what is it that stops more companies from going that route? What are the key challenges they are facing? Again, conversations with our customers help me to highlight 5 most common themes. First of all, the beginnings are often difficult. There needs to be a buy-in from the stakeholders, and that often involves proving the benefits and future savings. Closely linked with it is funding, another major challenge. Unfortunately, most water companies do not have enough capital budget to embark on major rehabilitation or replacement programs, and there is a major funding gap between what is available and what is needed. However, there is more and more recognition that figuring out the balanced level of proactiveness and doing enough can be the way forward. It does, however, require making the right prioritization decisions. There is definitely a pressure in the industry to spend already limited budget where it should be spent to get a good return on investment. And to help with those decisions, there are several new technologies out there, but it's challenging to know which one to use and how to get most out of them. So I had grouped the technologies that are currently on the market into 2 categories. First one are traditional ground-based solutions. Traditional in this case has nothing to do with their advancement or complexity, but with the fact that they will require one or multiple site visits. They are often applicable to one use case, for example, primarily targeting leakage, and they may require other technologies to make the most use out of them. On the other side of the spectrum, we have a fully remote solutions. They can use satellite technology or AI. Usually there are several use cases they can be applied to, and they tend to also work nicely with ground-based solutions by either helping to prioritize deployment or by consuming data that has been collected on site. I have 2 examples of ground-based solutions I wanted to briefly expand upon. First one is on-site deployed loggers or sensors, for example, acoustic or pressure loggers. And they are great technology for reducing leak runtime and reducing leak detection costs. They can help to save on cost of repairs. The water company I worked for in the past had this mantra of finding and replacing smaller leaks before they became bursts. And this is especially important on the large diameter mains. So there is a clear benefits there. However, despite of their price coming down a lot over recent years, there is still the high initial cost, especially if going for the full network deployment. And when considering more targeted deployment, it is likely to need other technologies to support those decisions. And many people forget that there is also a significant operational cost associated with them. They come from regular maintenance, repairs of loggers themselves, and also from regular software licensing for any platform or software used alongside the loggers. What also often comes up in conversations with our customers is that the high-frequency raw data from loggers may require post-processing to extract any insights. And let's not forget that these insights are mostly used for leak detection, so they don't necessarily support wider decision-making on their own. Second example of ground-based solutions are condition assessments. They had gone a long way from that pipe inspection photo on the right-hand side, with a new methods of condition testing emerging frequently. They do provide very useful insights into an actual condition of an asset, and are a great help when planning localized repairs and replacements. They are also a great source of training data. And that data can feed into more complex risk models or offer an option to validate results of those models. So condition assessments won't usually cover entire network, and there is the need to interpolate between survey points. Ideally, they would be linked with other technologies that help to prioritize what gets assessed and keeps the cost down. And also because of the dynamic growth in this area, there are several different technologies and vendors available. And our customers flag that stitching all those different data together and getting the full picture of risk distribution within their network can sometimes be challenging. Now, when we look at the other category, so satellite and AI solutions, we can find a number of examples here. They have some common similarities, such as all of them are remote. This then means that they can cover a large area of interest easily, something which is especially important for larger networks. They tend to scale better and usually have a subscription pricing models. There's no hidden operational costs, and they often have their built-in discounts based on the network length or area covered. Most of them can support several use cases. So, for example, be used in leak detection, in asset management, and they have some operational use. And this means savings and getting better value for money, because the cost of technology can be potentially shared by different departments. And this is very much something our customers are more and more interested in. Now, all of those solutions are not the same, so let's go through some examples and differentiators. First in line, we have satellite leak detection. It's been on the market for several years now. And although it's remote and covers large areas, and the insights it provides are mainly leakage focus. The technology is based on the principle of detection of water mixed with soil using satellite radar data, but there is a question here of this being applicable everywhere. For example, is it going to work in heavily built up areas and pipes under thick layers of concrete or tarmac? So does it really work in all environments? In conversations with our customers, it was also flagged that it can lack in precision. Output hotspots areas are usually quite large. They cover multiple pipes, so it's still reliant on that leak detection team to pinpoint the location. Second category are statistical data models, again, fully remote, but they often only consider a limited number of network attributes. And there are limited insights into the actual environment where each pipe is located. They are often trained globally, and although this is very great in terms of the big data sets that you can work with, it may not be applicable and fit every network. Because of this one global model scenario, there's also limited scope to improve results or to look at something more bespoke. Geographical transferability can also be an issue here. And finally, we have geospatial AI, like the one offered by Rezatec. It combines network data with a good selection of external sources, such as environmental data or satellite data from both optical and radar sensors. And this type of solution offers the benefit of large global data set, but also the benefit of bespoke machine learning model trained for your specific network. So in simple terms, it's the best of both worlds. It is highly accurate and precise, and it's constantly being improved as the technology evolves. So we talked about the solution types available out there and their pros and cons. Now, once water utility leaders decide which solution or a group of solutions would support them best, what are the next steps? What questions to ask when evaluating potential vendors? I had researched this by talking to our customers, but also to a wider group of water utility professionals, and narrow it down to 5 themes of questions. First of all, is how accurate the solution is. I think we all know that accuracy is a complex term and can depend on many factors. For example, in case of any models, it can depend on quality of the data that goes into the modeling. Nevertheless, there should be a clear benchmark number or a range of numbers, and it should come from extensive testing done with several beta users or customers. Currently, in everyday life, if we want to purchase something more expensive, we often turn to online reviews and other customer experiences to guide us and give us the confidence. It's not dissimilar with choosing a solution. The accuracy statements should be supported by things like case studies, quotes, customer advocacy, and also willingness to provide references. All of that should be frequently updated. It's good practice to check dates. If your potential vendor is doing things right and gets positive feedback from the customers, they're likely to shout about it and update it frequently. And below some recent examples of accuracy quotes from some of Rezatec's customers. Those are clearly stating the accuracy of 80 or nearly 80%. And this is an example of the sort of things to look out for. Now, closely linked with accuracy is precision. So how precise the solution is. Does it offer the good level of granularity when it comes to the results? Different use cases will call for different levels of precision. Asset management pipe replacement programs may be content with a large section of pipes that are candidates for replacement. However, in case of leak detection, from the feedback we get from our customers, they definitely want something more precise. The hotspot provided by some of the vendors can cover large areas and multiple pipes, and they still require a fair bit of work on the leak detection side. Having shorter sections of pipes, for example, something around 100 meters long, prioritized within the hotspots, just offer more value to leak detection. So after both accuracy and precision comes the validation question. How strong is the validation process and offering? Is your vendor even interested in validating their results? If not, is it perhaps a red flag straight away? Most vendors, if they know their product is good, will feel confident and happy to validate. Customers feeling confident that they are getting the value out of the solution means subscription renewals. And of course, customers want to know what they paid for, that what they paid for had worked. So you should not be afraid to ask if there are different validation options available. As a bare minimum for machine learning or AI solution, there should be model validation metrics available. Other forms of validation could include a desktop one, using your data and comparing predictions to the data that you withhold from modeling. And increasingly, vendors like, for example, Rezatec go a step further and offer an option of ground truthing using a local third-party leak or condition assessments contractors. So how could the results of those validation exercises be provided back to you? Here we have the sort of visuals that we use to prove accuracy to our customers. In this slide, comparison between highest likelihood of failure pipes as modeled by us versus the breaks that occurred after we had delivered results. In this case, to one of our US-based customers. In this example, we can see a high number of breaks in what we predicted as a top 5% highest likelihood of failure mains, which is a great prediction rate, and customer was very happy with that. And this is another example. This slide looks at the different breakdown of breaks per mile or miles searched per break. Again, for the same customer and showing a clear benefit of using geospatial AI. Those are the sort of metrics and different ways of presenting the data that can lend themselves nicely to building ROI models and business cases. And finally, comparison between what has been modeled and data captured by condition assessments. In this case, showing a significant alignment towards highest risk bracket on breaks found on poor and below average pipe conditions. Those were just examples of the validation and how its results can be visualized. And this is to build your and your teams or stakeholders' confidence in the solution. Now, accuracy, precision, validation are all important, but what happens if the results don't meet the benchmark level, or even they do, but there is a feeling improvements could be made? Are there plans for future improvements? Is customers' voice being listened to? Most of our customers say they would like to step away from the drop and go data model. And when they say drop and go, what they are referring to is vendors that give them results as agreed, but it's where the conversation ends. There is no real scope for changes, future improvements, and customers have no ways of providing feedback and feeding into future development. There are two parts of this. It's important there is that option for improvements if there are needed, but also in general, the solution should evolve and be continuously reviewed as the new data becomes available, or perhaps as the technology evolves. We had provided here a particular example and a case from our engagement with WaterOne. This has been taken directly from one of their external presentations. So at the beginning of our engagement with them, we set a minimum threshold of 70% accuracy. And after delivery, Rezatec and WaterOne each had a week to separately validate the results. We came back and compared the notes. We've reached 73% of accuracy number. But although it met the minimum criteria, it was flagged that a data cleanup step in pre-modeling phase could make things better. So Rezatec worked together with WaterOne again and applied changes, and those changes resulted in increased accuracy of 78% during the second model run. And based on that good results proves the willingness to listen to our customers and drive continuous improvements. We are gearing up to expand the analysis from the initial 250 miles of network to 1,100 miles to support the future replacement plans. And our final theme of questions is about the way the results are being presented back to you. Most important point here is that the results you are receiving should support your use case or multiple use cases. Ideally, what you get back can directly plug into your team workflows without your team needing to spend extra time trying to make it work. Our customers flag it as something that could prevent them from making the best use out of solution, given how overstretched they are in terms of resources. In Rezatec, we have ability to provide a good granularity of our analysis, something that is appreciated in certain situations, for example, when using likelihood of failure scores in leak detection. But in case of WaterOne, the main replacement use case called for a different approach and development of asset and street level dashboards. This allows for flagging larger lengths of pipe or whole streets that would be a good candidate for replacements. And this for them meant cutting out the step of someone in their team trying to group pipes into those logical groups and candidates for replacement schemas. So again, the question about possibility of tailored data aggregation should be definitely considered when choosing the vendor. So before we open up to questions, a quick summary of what we had covered today. There are a number of solutions, technologies out there that can help with being more proactive. They can be more ground-based or remote. They can support one or multiple use cases, be they more standalone or work better when combined with another technology. And when looking at remote solutions especially, there are 5 key questions to ask. So how accurate it is, remembering about all important evidence to support accuracy statement, how precise it is, and is it enough for what you want to achieve? Is vendor not afraid of validation and willing to validate with you, and how strong is the validation offering? Are they willing to improve, and is there a plan or roadmap for model improvements and future releases? And finally, how does the tailored aggregation work, and is there option to have it tailored in the first place? So all those vendor questions are very much around the value you are getting from the technology or solution. And I had on purpose not included the question of price here. In a way, as I had flagged before, not all solutions are equal, and you need to know the value of what you are getting from each vendor before bringing the price into the equation. And probably last important thought here before Q&A is there are vendors out there who would also happily help you with return on investment calculations and putting together a strong business case. We certainly did this at Rezatec for a number of customers. So it's also good to keep this in mind, that sort of help can be available on request.